Alright, you guys, we are going to talk about numbers 22 through 40 even. So number 22, it says write an equation in slope-intercept form of the line shown. So remember, this is y equals mx plus b, where m is the slope and b is the y-intercept. So I want to start with that y-intercept. Looks like my line hits right here on the y-intercept. So in my equation for my line, this b is going to be 1. So y equals something x plus 1. From there, I want to look and see the consistent slope of my line. Looks like it hits at this point and this point. So you want to think rise over run for your slope. So from the left to the right, you want to rise 1, 2, 3 over 1. So your slope for this equation is going to be 3 over 1, which is the same thing as 3. So this would be the equation of my line. The next few sections are talking about solving systems. We solve systems in several ways, one by substitution, one by elimination, and one by graphing. This example is by substitution. Remember, when you're substituting, you are plugging in for a different variable. So here, I've got x equals y minus 3. So I like to put parentheses around this because that's what x equals, and then draw an arrow to where you're going to plug him in. You're going to plug him in for the x. So you can rewrite this as 4 parentheses y minus 3. Instead of writing that x, I'm going to write y minus 3. Then I continue with my equation. Plus 3y equals negative 5. Now I would solve it just like any other equation. First thing I want to do is distribute here. 4 times y is 4y. 4 times a negative 3 is negative 12. Plus 3y equals negative 5. Combining your like terms here. 4y plus 3y is 7y. Minus 12 equals negative 5. Then you would add 12 to both sides. 7y equals negative 5 plus 12 is 7. 7y divided by 7 on each side, and you get y equals 1. So in your answer blank here, you're going to write your answer as a coordinate point, so it should be something comma something. Y is going to be 1. Now to go back and find out what x is going to be, all you want to do is take this answer and plug him in or substitute him in for the most simple equation. So I'm going to take it back to x equals, and it tells me y minus 3. Well, y is 1, so I do 1 minus 3. 1 minus 3 is point, I've got negative 2 comma 1 as my answer. The next section, solving systems, but this time it's by elimination. Elimination, if you remember, we cross out and combine. So for number 26, you want to look for something that's going to eliminate or cross out, and then you're going to combine everything else. I noticed that my y's, I've got a negative y and a positive y, so those are going to eliminate, and I combine everything else. 3x plus 2x is 5x, and I've got an equal sign. 9 plus 1 is 10. You can put a little plus signs there. From here, just going to divide by 5 to solve. X equals 2. Just like we did in the previous equation, you go back and plug this guy in to the most simple equation. So instead of, I'm going to use the second equation, and instead of x, I'm going to put 2. So 2 times 2 plus y equals 1. And I'm going to solve for y. 2 times 2 is 4, plus y equals 1. Minus 4, y equals a negative 3. So you've got x is 2 and y is a negative 3. So in your coordinate point notation, that'll be 2, negative 3. My next section is talking about exponents. So if you remember Maths RM, when you're multiplying, you add. When you're dividing, you subtract. And when you're raising, you multiply them. So here, 28, I'm multiplying, so I'm going to add these exponents. 4 plus 6 is 10, so I get x to the 10. When you look at number 30, the first thing you want to do, you've got some exponents that are being raised to more exponents here. You want to distribute him. Remember, when you're raising exponents, you multiply them. Negative 5 to the third and m to the 12th times m squared. I know I can simplify this. Negative 5 cubed is negative 125. And I know I can simplify here. M to the 12th times m to the second. When you're multiplying, you add them. So it's m to the 14th. And that's your final answer there. Number 32 moves on to quadratics. Says write an equation of a quadratic graph. So that would be similar to y equals ax squared plus bx plus c. But it's going to open down and has a y-intercept of 8. So I want to remind you guys of what we learned about quadratics. A tells me if it opens up or down. If A is positive, then it opens up. If A is negative, it opens down. A also tells me if it's skinny or wide. And we don't have that in our problem right now, but you may at some other point. This C is also my y-intercept. So that's something to keep in mind as well. So all my information that I'm given here is that I want to open down. So I'm going to make A negative. So y equals negative, let's say 1, x squared. And then it tells me the y-intercept is going to be 8. So I'm just going to go ahead and leave out my regular x's and just put plus 8. That would be an example of a quadratic that opens down and has a y-intercept of 8. Turning the page to number 34. Factor the trinomial. If you remember, we used the x for this. We said a times c goes at the top, b goes at the bottom. So for here, a is 1 times c is a negative 24. b is at the bottom. So you're thinking what multiplies to give you a negative 24 and adds to give you 2. Here in my class, we talked about how if the second sign is negative, then you know your signs are going to be opposite. You look back and it says the larger is. The larger is negative. So when we list out all of our factors, we're going to keep the larger numbers negative. So think about what multiplies to give you 24. You know, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Keeping all the larger numbers, larger numbers positive. Larger numbers positive. Because this one's positive, and when they add, they're going to be positive. So your small numbers are going to be negative. You guys will have to forgive me for that. So you want to look for a combination that's going to add to give you a positive 2. That combination will be right here. So I'll have a negative 4 and a positive 6. They'll multiply to give you the top, negative 24. They add to give you the bottom. So that would be your answer, x minus 4 and x plus 6. Same thing for number 36. You're going to look for what multiplies to give you 9. You know the plus sign right there tells you your signs are going to be the same. Then you look back at this guy, it says they are both negative. So you're looking for two numbers that multiply to give you 9, and they're both going to be negative. And then you want them to add to give you a negative 10. So you've got 1 and 9 and 3 and 3. Those are all your factors of 9. Then you want to look for which ones are going to add to give you a negative 10. That would be these guys. Negative 1 plus negative 9 is a negative 10. Negative 1 times negative 9 is 9. So you've got x minus 1 and x minus 9 as your final answer. You can always multiply this back out, FOIL it back out, and double check to make sure your FOILing gives you what you started with. Number 38 asks us to complete the table and the graph of this equation given the domain. Remember, domain is your x values. So you're going to list all of these x values here. And then we're going to plug them in order to solve for the y. So you would plug in y equals 2 times a negative 1 minus 6. 2 times a negative 1 is a negative 2. Minus 6 is a negative 8. Plug in the 0. 2 times 0 is 0. Minus 6 is a negative 6. Plug in your 3. 2 times 3 is 6. Minus 6 is 0. Then you'll plug in your 4. 2 times 4 is 8. Minus 6 is 2. So now you've got all these x values and all your y values. You put them together as coordinate points. Negative 1, negative 8. 0, negative 6. 3, 0, and 4, 2. And you would want to plot each one of those points. Negative 1, negative 8. 0, 6. 3, 0. And 4, 2. You want to draw a straight line between those. And then it asks you to identify the range. And the range are all your y values. So you just open your brackets like so and list out your range. Now speaking of domain and range, this next section is asking us whether or not we have a function. Remember, a function is whenever your x's have exactly one place to go. Okay, whenever your x's have exactly one place to go. So if I look at my table here, x, y, remember your domain is your x's and your range is your y's. And I list out my domains, and then I list out my ranges, 3, 1, 2, and 4. And I can map them out. I can point them to their partners. So 6 goes with the 3, 3 goes with the 1, 0 goes with the 2, then 3 also goes to the 4. That's called mapping. And what you want to look for is whether or not each x has exactly one place to go. This x, number 3, has 2 places to go. It's got a 1 and it's got a 4. When it has 2 places to go, this is not a function. And it's because of the 3. The 3 has 1 and it has the 4. So because of that repetition for number 3, it is not a function. Alright, you guys, well that is it for our second video, numbers 22 through 40. Come on into tutoring if you have any questions.